Hey guys, welcome back to my channel. Today's topic is isomerism and projections. Doing the answers from my previous video, the first question was which one of the following is not conjugated, and the answer is A. This was the structure, and it is not conjugated because these two are functional groups. There is no double bond in the whole system between the carbons, so it is not conjugated. These are aldehyde functional groups. The second question was whether the phenyl group is mesomeric positive, negative, inductive. So the answer is mesomeric positive. Why? Because the hydroxyl group attached to the benzene ring is electron donating. It pushes the electrons towards the structure. Now moving on to our topic for today, we have isomerism. So starting with structural isomerism. So if you remember, isomers are compounds with the same molecular formula but different structural formula. So the structural isomers, they have just different placement of the molecules or atoms. So for example, here we have butane, which is C4 and H10. So butane has two isomers. The first one can be drawn like this, which is a straight line one. So you can see that there are 4 carbons and 10 hydrogens. And in the second way it can be drawn is with a side chain. For example, the methyl groups goes in the center. So these are the only two ways you can draw butane, and that's why we say that butane has 2 structural isomers. If you compare both these compounds, you can see that both of them have 4 carbons and 10 hydrogens. Now there's another kind of isomerism. It is called tautomerism. So it is based on the exchange of a hydrogen atom between 2 other atoms. Now, for example, we have this structure, and in tautomerism you need to have a keto group, which is a C double bond O. So when you have this, the enol form will look like this. So you have to move the double bond to the neighboring side, adjacent side, and then one hydrogen goes to the oxygen, not the same hydrogen that is in the first compound. So this is what it looks like. You're going to have the double bond between the carbons instead of between the carbon and the oxygen, and you're going to have a hydrogen attached to the oxygen. So you get an enol form, which is an alcohol form, which is hydroxyl group OH. Here is another example. So we have a cyclohexane and we have a double bond, so it's cyclohexene, and we have an OH group attached. So this will be the enol form, right? Because of the hydroxyl group. Now, if we have to show tautomerism in this structure, you're going to have to move the hydrogen and move the double bond to the adjacent side. So for the keto group, we said we need the keto functional group. So we need the C double bond O. So what happens is that we take the double bond to the other side, and then the H goes to the carbon. But in a cyclic compound, you don't really show the H's. You can just draw it like this. It's the skeletal form. Now we'll move on to stereoisomers. We have done this already in the previous video, but I'll speak about it again. So in stereoisomers, you have optical isomers as well, and these are enantiomers, which are non-superimposable mirror images, and the opposite of enantiomers is distereomers, which are superimposable on mirror images. So this is something I've wanted to tell you. And the other type of stereoisomers is geometric isomers, which you know, I even gave you a homework question on it. So let's do an example here. Geometric, we had cis and trans. So here we have a compound. You can see that this is a trans. Why? Because the functional groups, the same functional groups, for example, methyl group, are on opposite sides, and so are the hydrogen groups. But in this one, which is the isomer of it, which is the cis isomer of it, it is the methyl groups are on the same side. Now I want to tell you something about chirality. So there are some molecules called chiral compounds which have a chiral carbon. So, and this is denoted by an asterisk next to the carbon in the compound. So what does it mean? It means a chiral carbon has 4 different bonds or 4 different atoms. So for example, between these 2 structures, which one would be chiral? You can see that this compound has a chiral carbon and is a chiral compound because of the 4 different types of bonds. Now moving on to projections, first we'll start with amino acids. This is called Fischer projection and it is seen in amino acids. So for Fischer projection, you have 2 different forms. You have L and D. So the D stands for dextra and it is negative. Then we have L, which stands, to make it easy, you can say for left, but it is actually for lever, and it is positive. So the Fischer projection of the amino acid, it depends on the amine group. So if the amine group is on the right, it is going to be dextra. If it's going on the left, it is going to be L. So here's an example. We're going to draw an amino acid. An amino acid always has the functional groups, the carboxylic acid and the amine group. So this amino acid, for example, is alanine. You can see that the amine group here is on the left side, and therefore this compound is going to be L positive alanine. And you can see that this carbon has an asterisk and hence it is a chiral compound because it has 4 different groups surrounding it. The next projection is seen in carbohydrates and this is known as the Haworth projection. In this you have 2 types again, one is alpha and one is beta. In carbohydrates, it depends on the hydroxyl group only on the right side of the compound. So if the hydroxyl group is down, it is alpha. If it is on top, it is beta. So here's an example. We're going to draw a fructose molecule, not really with the functional groups, just the basic ribose structure. So this is what a normal ribose sugar will look like. You can see on the right side, which is very important, that the hydroxyl group is on the top. So this compound is going to be beta fructose, for example. If it was on the bottom, it would be alpha fructose. Now some questions for homework. The first question will be, which one of the following compounds is a chiral? Is achiral. So achiral is the opposite of chiral, so which one of the following is not a chiral compound? Is it A? Is it B? Or is it C? The second question is, show tautomerism of the following compound, and you can even state if it is the keto form or the eno form. And the last question for today will be, show all the possible structural isomers of pentane, which is C5H12. And that would be it for this video. Hope you enjoyed it. I'll see you in my next one. Bye.